They say the universe is stranger than we can imagine, but every so often, it whispers something so wild, so improbable, that it shakes everything we thought we knew. One of those whispers comes from a small, fiery moon orbiting a giant, Jupiter. Its name is Io, and what NASA has found there shouldn't exist. To understand why Io is so extraordinary, we need to step back for a moment and remember how we first discovered it. In the winter of 1610, an Italian astronomer named Galileo Galilei pointed a small telescope toward Jupiter. What he saw forever changed humanity's understanding of the cosmos. Tiny points of light moved around the giant planet night after night. These were not stars, they were moons. Among them was Io. For centuries, Io remained little more than a moving speck of light in telescopes. Astronomers could track its orbit, calculate its position, and measure its brightness. But the true nature of Io remained hidden behind distance and mystery. No one suspected that this small moon would eventually reveal one of the most violent landscapes in the entire solar system. That revelation came in 1979 when NASA launched one of the most ambitious planetary exploration missions ever attempted, Voyager 1. As the spacecraft sped past Jupiter, scientists expected to see a surface similar to our own moon, ancient, cratered, and frozen in time. But when the first images of Io arrived on Earth, the reaction inside NASA's control rooms was stunned silence. Io was not ancient, it was not quiet, and it was definitely not frozen. Instead, the images revealed something no one had ever seen before on another world: erupting volcanoes. Massive plumes of material were shooting hundreds of kilometers into space. Bright scars of fresh lava stretched across the moon's surface. Entire regions appear to be reshaped by ongoing eruptions. For the first time in history, humanity had discovered active volcanoes beyond Earth, and they were everywhere. Today, scientists estimate that Io contains more than 400 active volcanoes, making it the most volcanically active object in the solar system. By comparison, Earth has about 1,500 potentially active volcanoes, but Earth is vastly larger. Io accomplishes this chaos on a world barely bigger than our own moon. But the question that puzzled scientists was simple: where was all this energy coming from? Volcanoes require heat. On Earth, that heat comes from radioactive decay and the leftover energy from our planet's formation. But Io is too small to maintain such intense internal heat on its own. By all logic, its interior should have cooled billions of years ago. And yet, Io burns brighter than any other volcanic world we know. The answer lies in an invisible force: gravity. Io is trapped in a constant gravitational struggle between Jupiter and two of its neighboring moons, Europa and Ganymede. As Io orbits Jupiter, the immense gravity of the giant planet stretches and squeezes the moon like a cosmic stress ball. Imagine bending a metal wire back and forth again and again. Eventually, friction builds heat. Now imagine that happening to an entire moon. Every orbit, Io flexes by as much as 100 meters. Its crust bends, its interior churns, and the friction generates unimaginable heat. This process is known as tidal heating, and it effectively turns Io into a planetary furnace. Deep beneath the surface, rock melts into enormous oceans of magma. Pressure builds, and eventually, the crust breaks. When it does, the results are spectacular. Volcanic plumes blast material hundreds of kilometers above the surface. Lava fountains erupt across plains of sulfur and rock. Entire landscapes are resurfaced in a matter of months. Some eruptions on Io are so powerful that the energy released surpasses all volcanic activity on Earth combined. To witness such an eruption would be both breathtaking and terrifying. Imagine standing on a ridge overlooking a vast lava lake. The ground trembles beneath your feet. The air shimmers with heat. Suddenly, the surface fractures, and a column of glowing material erupts skyward like a geyser of molten fire. Ash and sulfur rain down across the landscape, and somewhere above, Jupiter hangs enormous in the sky. 20 times wider than our moon appears from Earth. It would dominate the horizon, a swirling giant of storms and clouds, watching silently as Io tears itself apart beneath its gravitational grip. But the surprises do not end there. because Io's surface is unlike anything else in the solar system. Most moons are grey, covered in craters formed by ancient impacts. Io, however, is a riot of colour. Yellow plains stretch across its surface, tinted by sulfur deposits. Bright reds mark areas where volcanic gases have frozen after erupting into space. Dark patches reveal fresh lava flows still cooling after violent eruptions. It looks less like a moon and more like a living painting. These colours are constantly changing. A region that appears bright yellow today might turn black tomorrow after a fresh lava flow sweeps across it.
In fact, scientists have watched entire landscapes transform in just a few years. Few places in the solar system are this dynamic. And yet, one of Io's most mysterious features rises above the lava plains like monuments carved by an alien sculptor: its mountains. Some of these mountains tower more than 18 kilometers high, making them taller than Mount Everest. But unlike mountains on Earth, they are not formed by colliding tectonic plates. Io has no plate tectonics. Instead, scientists believe these mountains are created when immense pressures from tidal forces cause huge blocks of crust to suddenly break and tilt upward. Imagine a massive slab of planetary crust, hundreds of kilometers wide, being pushed upward like a giant wedge. The result is a mountain that appears almost overnight on geological timescales. One of these towering formations is known as Steeple Mountain, a jagged peak rising dramatically above the volcanic plains. Its slopes are steep and fractured, its summit razor-sharp against the blackness of space. Standing there would feel like standing on the edge of another universe. And yet, even with all this violence, Io possesses something incredibly delicate: an atmosphere. It is not thick like Earth's atmosphere. In fact, it is so thin that if you stood on the surface without a suit, you would barely notice it. This atmosphere is made mostly of sulfur dioxide gas released by volcanic eruptions. When the sun shines on Io, this gas sublimates from the surface and forms a faint atmospheric layer. But when Io moves into Jupiter's shadow, temperatures drop rapidly. The atmosphere literally freezes and collapses onto the surface. Then, when sunlight returns, the frozen gases evaporate again, rebuilding the atmosphere in a repeating cycle. An atmosphere that appears, disappears, and reappears every single orbit. It is a fragile breathing of the moon itself. But perhaps the most fascinating discoveries about Io have come in recent years thanks to NASA's spacecraft Juno. Launched in 2011, Juno arrived at Jupiter in 2016 to study the giant planet in unprecedented detail. Over time, the spacecraft also began capturing remarkable images of Io during close flybys. These images revealed lava lakes larger than entire cities. One of the most famous is Loki Patera, a vast volcanic depression nearly 200 kilometers across. Inside this enormous basin lies a lake of molten lava whose surface periodically overturns, releasing massive bursts of heat detectable from Earth-based telescopes. It is essentially a lava ocean. Imagine an area larger than many countries filled with slowly churning molten rock, and it is only one feature among hundreds. Yet perhaps the most unsettling aspect of Io is the realization that its activity never truly stops. While Earth's volcanoes may sleep for centuries before erupting again, Io rarely rests. Somewhere on its surface, a volcano is almost always erupting. It is a world in constant transformation, a world where destruction and creation are inseparable. And perhaps that is what makes Io so mesmerizing. Because in many ways, Io represents the raw forces that shaped every rocky world in our solar system, including Earth. Billions of years ago, our own planet was covered in oceans of lava. Volcanoes dominated the landscape. Continents had not yet formed. Life had not yet appeared. Earth once looked far more like Io than the peaceful blue world we know today. In studying Io, scientists are not just observing a distant moon. They are looking back in time, glimpsing the violent origins of planets themselves. But Io also reminds us of something deeper. The universe is not quiet. It is not static. It is dynamic, chaotic, and endlessly creative. Worlds are born, reshaped, and destroyed by forces far beyond human control. And yet somehow, we are able to witness it. Tiny beings on a small blue planet have built machines capable of traveling hundreds of millions of kilometers to photograph a fiery moon orbiting a distant giant. That alone is extraordinary. Perhaps that is why Io feels so haunting. It is not just a place. It is a reminder of the scale, power, and mystery of the cosmos. Future missions will continue exploring the Jupiter system. NASA's Europa Clipper and the European mission JUICE will study the icy oceans hidden beneath the surfaces of Jupiter's other moons. But Io will remain something different, something untamed, a world of fire, fury, and relentless transformation. And far above its burning plains, Jupiter will continue to loom in the sky, an enormous reminder of the gravitational forces shaping everything below. Io will keep erupting, its lava lakes will keep glowing, its mountains will keep rising, and the universe will continue whispering its impossible stories. Because the truth is simple, what NASA found on Io shouldn't exist, and yet, against every expectation, it does. But the story of Io does not end with lava lakes and towering mountains. In many ways, those discoveries were only the beginning. Because the deeper scientists looked, the stranger this moon became. One of the most surprising revelations about Io is that its eruptions do not just shape the moon itself. They influence an entire region of space surrounding Jupiter. Every time a volcano erupts on Io, enormous amounts of sulfur and oxygen are blasted high above the surface. Some of this material escapes Io's weak gravity entirely. Instead of falling back down, it drifts outward into space. But space near Jupiter is not empty. The giant planet possesses the most powerful magnetic field of any planet in the solar system. This invisible field extends millions of kilometers into space, trapping charged particles and accelerating them to incredible speeds. When the gases escaping from Io encounter this magnetic field, something remarkable happens. They become ionized, electrically charged, and begin to swirl around Jupiter like glowing threads of plasma. Over time, these particles form a massive ring of energized gas encircling the planet. Scientists call it the Io plasma torus. It is one of the most energetic environments anywhere in the solar system. Imagine a giant invisible donut of electrified particles stretching hundreds of thousands of kilometers around Jupiter. This torus constantly feeds energy into Jupiter's magnetosphere, creating powerful auroras that shimmer across the planet's poles. In a strange way, Io is not just a moon. It is a cosmic power generator. Its volcanoes feed Jupiter's magnetic environment, creating an enormous electrical circuit that connects the moon and the planet in ways scientists are still trying to understand. This relationship is so powerful that electrical currents actually flow between Io and Jupiter through magnetic field lines. The result is a glowing footprint of energy in Jupiter's atmosphere, an auroral spot that marks Io's position as it orbits the giant planet. In other words, a small moon barely larger than Earth's own moon is capable of influencing the space environment of the largest planet in our solar system. It is a reminder of something profound. In the cosmos, size is not always the measure of importance. Sometimes the smallest worlds hold the greatest power. And yet, even with all these discoveries, Io still refuses to give up all its secrets. Scientists believe that beneath its fractured crust lies an enormous ocean of molten rock, an underground magma layer that may span much of the moon's interior. This magma ocean could be tens of kilometers deep, constantly stirred by tidal forces as Jupiter's gravity squeezes the moon again and again. The crust above this molten layer behaves almost like the shell of a cracked egg. Pressure builds below, and when that pressure finds a weakness, lava erupts violently onto the surface. Some of these eruptions produce enormous umbrella-shaped plumes that rise 300 to 500 kilometers above the moon. To put that into perspective, that is higher than the International Space Station orbits above Earth. From orbit, these plumes appear like giant fountains of dust and gas spreading outward across the moon's surface before slowly settling back down. Over time, they paint the landscape with bright rings of sulfur frost. These rings can stretch hundreds of kilometers wide, leaving behind colorful scars that remain visible for decades. And because Io is constantly active, new eruptions can cover old landscapes in fresh lava flows, erasing geological history almost as quickly as it forms. In fact, Io's surface is so frequently renewed that impact craters are extremely rare. Most worlds in the solar system are covered in craters formed by ancient asteroid impacts. But on Io, volcanoes resurface the moon so often that these craters disappear. It is a place where the past is constantly buried beneath the present, a world where geological history is rewritten again and again. But perhaps the most mesmerizing feature of Io is something scientists call Loki Patera. Loki Patera is not just a volcano. It is believed to be the largest lava lake in the entire solar system. Stretching nearly 200 kilometers across, it forms a vast horseshoe-shaped depression filled with molten rock. The surface of this lava lake behaves almost like a shifting crust. Over time, sections of cooled lava become too heavy and sink back into the molten magma below. When this happens, fresh lava rises to the surface, releasing enormous bursts of heat and light. Astronomers on Earth can actually detect these brightening events through powerful telescopes. Even from hundreds of millions of kilometers away, Loki's eruptions are visible. It is as if the moon itself occasionally flickers like a cosmic lighthouse. These eruptions follow patterns that scientists are still trying to decode. Some appear to repeat roughly every 400 to 600 days, suggesting complex cycles within the magma beneath the surface. But the truth is, Io still refuses to behave exactly as predicted. It continues to surprise us. And perhaps that is what makes it so compelling. Because Io reminds us that the universe is not finished revealing its secrets. Every mission, every telescope, every new observation peels back another layer of mystery. But behind that layer lies another question, and another, and another. In many ways, Io represents the raw engine of planetary evolution. Before Earth became a calm world of oceans and continents, it too may have resembled something like Io, covered in magma oceans, battered by impacts, and reshaped by relentless volcanism. Io shows us what a young, restless planet might look like. It is a window into the early history of worlds. But it is also a reminder of something more philosophical. When we look at Io, we see destruction everywhere. Lava floods, collapsing mountains, explosive eruptions. Yet within that destruction lies creation. New landscapes are born from molten rock, new mountains rise from shattered crust, and new discoveries emerge every time we observe the moon again. Creation and destruction are not opposites here, they are partners. And that idea echoes throughout the universe. Stars explode to create the elements that form planets. Planets collide to create moons. Worlds erupt, crack, and reshape themselves across billions of years. The cosmos is constantly rebuilding itself. Io is simply one of the most dramatic examples of that eternal process. Far above its fiery plains, Jupiter continues to loom enormous in the sky. Storms swirl across its clouds, including the ancient hurricane known as the Great Red Spot, a storm larger than Earth itself. From Io's surface, Jupiter would dominate the sky like a colossal celestial wall. It would rise slowly over the horizon, casting faint light across the volcanic plains. And somewhere beneath that towering planet, lava would continue to flow. Mountains would continue to rise, and the moon would continue its endless dance around its giant master. For now, Io remains a distant world, too hostile for human exploration, too violent for any lander to survive for long. But that does not stop us from studying it. Spacecraft continue to pass through the Jupiter system, capturing glimpses of Io's restless surface. Telescopes on Earth monitor its eruptions from afar, and scientists continue to build models, simulations, and theories to understand what is happening beneath its crust. Because every new discovery about Io brings us closer to understanding not just one moon, but the fundamental forces that shape planets everywhere. Gravity, heat, pressure, time. These forces sculpt the universe on every scale, from the smallest asteroid to the largest galaxy. And Io, blazing with volcanic fury, is one of the clearest reminders of how powerful those forces can be. It is a world that should have cooled billions of years ago, a moon that should be quiet and frozen like so many others. And yet it burns, relentlessly, endlessly, beautifully. Because the truth is simple. What NASA found on Io shouldn't exist. And yet, out there in the darkness, orbiting a giant planet nearly 800 million kilometers from Earth, this impossible world continues to erupt, reshape itself, and challenge everything we thought we understood about the universe. And maybe that is the most important lesson Io has to offer. The universe is not limited by what we think is possible. It is far stranger than that, far more powerful, and infinitely more mysterious.